Okay, students, welcome to our Unit 4 Part 2 review. This is for 11 and 413 in the content. Alright, some information to save or to remember. This first part right here, inverses, deals with 413, and compositions down here deals with 411. So let's go ahead and start with compositions. If you remember right, the last video talked about operations with functions. And operations with functions were like adding and subtracting and multiplying and dividing them. Composition of functions looks a little bit different, although you might mistake it as being multiplication. You see that there's that circle thing, kind of looks like multiplication in between these, but it's bigger and it's more open. That is called the composition of the function. So what this means is it means that we have f of g of x, and we can see that written like this as well. In fact, I kind of like it more written like the second part here, because then you're not making the mistake of saying, well, is that multiplication or what is that? So f of g of x means that you're going to take g of x and you're going to put it into f of x. So not only are we're not talking about multiplying, dividing, and subtracting and adding now, we're talking about taking one function and putting it into the other. So it's funny because my students think of it as function inception. So you're taking one and you're putting it inside of the other, okay? And that is what function composition is. So inverse functions then are when we have the domain of the inverse function, okay, is the range of the original, and the range of the inverse function is the domain of the original. So our x's and our y's are switching. And we note inverse functions as this right here. And it looks kind of like that could be f to the negative 1 power, but that does not mean f raised to the negative 1 power. This notation may seem confusing, but it's the standard way of denoting inverse functions. So whenever you see like a little negative 1, it looks like to the negative 1 power, that means inverse functions, okay? Inverse functions. And we're going to start with the composition of functions. So here are our two functions, and we're being asked to compose it in this manner. So I want to rewrite it for just a second as f of g of x, just so maybe we can see what's happening here. And if I remind you that when we have, and I'm just going to do a little example up here, if we're trying to find f of 2, okay, I want to remind you that we take that 2 and we plug it into everywhere we see an x on f. So we plug it into 2, and there's the x times 2. And so wherever we saw the x, we put a 2 in its place, okay? And then we went ahead and solved this. So f of 2 would equal 4. Now, what we're saying down here in this problem is f of g of x. So do you see how g of x is in place of the 2? So now we're going to take that g of x and we're going to put it into wherever we see x on the f. So let me write it like this. I'm going to write it as f of, and g of x is x minus 7. So f of x minus 7 equals 2, and remember there's a times sign, or I like to put all of my, whenever I plug in my compositions here, I like to put them in parentheses. So I'm going to write it as 2 and then parentheses x minus 7. Okay, and that's really what we see here. Okay, it kind of combined them. So we plugged in the second function into the first function, so the second function was g of x, see it there? and we plugged it into wherever we saw x in the first function. Okay, so then third step here says to simplify. Okay, and I think of this as distributive property. Remember how we have distributive property? So I'm going to rewrite just that right-handed side of the function there, and I'm going to distribute. So here I see that I need to take the 2 and multiply it to the x. I also need to take the 2 and multiply it to the 7. And so what I get is 2x, and 2 times -7 is -14. And guess what? That is your answer. That is what f of g of x equals, because I am not given a value for x. So if there's still an x left up here in the directions of the problem, then you're going to be left with an x of in your answer. Okay, let's try another one. So this time it says, I want you to know g of f. Okay, so now we're going the other direction, so make sure you're plugging into the correct things. And it also gives you a value. So because it gives us a value, we're now going to see that we have just a number at the end. We're not going to have an x in our answer. Okay, we have a few different directions because I think it's easier to first plug in the value and then put it into the other one. So my directions say, or my steps say, to plug the given value into the second function. So I'm going to first find, that's supposed to be an f of 3. Okay, f of 3. So I'm going to take 3 and plug it into my f function, wherever I see an x. So I like to remember to put parentheses. So I'm going to put 3 squared, and 3 squared equals 3 times 3, which is 9. So that means f of 3 is 9. Now, second step says to plug your answer from step 1. So here's my answer. And plug it into the first function. So now I'm going to find g of 9. And when I do that, I plug it in wherever I see an x in that g function. So it's 4, and then I'm going to put parentheses, which means times 9 plus 5. And so if I simplify or evaluate like step 3 says, I'm going to get 4 times 9 equaling 36, and 36 plus 5 equals 41. And so my answer to f of g, or g of f of 3, is 41, and that is your final answer. Okay, so what happens then if we see g of g? Oh my goodness. So this one's a little bit different because I'm taking the g function and plugging it back into itself. So I'm composing two g's, okay? But I give you a value here. So remember, we can plug this value in first, make it easier on us, and then take that amount and put it back into it. So I'm going to first find g of 15. And so watch what happens. 15 goes in place of x of that g function. And so I have 15 minus 7. And that equals, when I simplify, 8. And so now for the second function, I'm going to find g of 8. I'm still dealing with the g function because it says right here, g of g. Okay? And so now when I plug it in, I get 8 minus 7. And my final answer here when I evaluate is 1. And so g of 15 equals 1. Okay, let's move on and talk about inverses. So I can find inverses, inverse functions, and evaluate them. So remember, if it gives you an amount, say, I want you to find the inverse of -3, so there's an amount in the place of the x, okay, then that's when we evaluate. But if there's not, then we don't evaluate it and we just have an answer of, we're left with an x in our answer, okay? So here are our steps. This one just wants us to find the inverse function. We're going to replace f of x with y. Literally just write y in place of f of x. So I'm going to put y equals 3x plus 1. Step 1 is done. Step 2 says to exchange x and y. Remember, inverse functions, the x's and the y's are switched. So we're going to take and put an x in place of y and a y in place of x. And rewrite everything the same. Okay, so then step 3, and this is where we get the bulk of our information here. Step 3 says to solve the equation for y. So this is, we have to go back to solving equations and we have to think, how am I going to isolate and get this y by itself? Okay, so first we undo the subtracting and adding. The opposite of adding 1 is to subtract 1. So I'm going to subtract 1 from this side, and that gets rid of it. And when I subtract it from the other side, I want to subtract it next to it. So this is x minus 1 equaling 3y. Now the reason why I put it next to it is because I cannot subtract 1 from x. 1 is not an x, and I cannot subtract them. And that's kind of hard to see. I'm going to go, let's change it to purple. I feel like that's really bright or something. Okay, so I have x minus 1 equals 3y. So I have one final step then to get my y by itself. This is saying 3 times y, so to get rid of it, I divide it, and I get y on this side. Okay, and then this side gets a little tricky. I like to divide each one by 3 instead of just putting it underneath the whole thing. And so I'm going to go ahead and write it under each one. And so this to me represents x over 3, or I could say 1/3 x, okay, and then minus 1/3. Now my last step, if I'm trying to write the inverse function, says to replace the y with the inverse notation. So I would write it as, and I'm going to write it first, hopefully that does not confuse you. F, and then the inverse function, remember, was the -1 there, and x still in between. And then it's going to be equal to x over 3 minus 1/3. And that is my answer because I have that x up there in the original problem. It's not asking me to evaluate it. It's not asking me to find what that equals. It's asking me just to rewrite it. And so there's my answer for my inverse function. Okay, so now this one is an evaluating one. So do you see how right here it says find g, the inverse g of 2? So we're going to follow the same process, but down here at step 4, we're going to plug the value in for x instead of writing the inverse notation. So I'm still going to write it as y equals 8 plus 2x and I'm still going to interchange my x and my y. So this becomes x equals 8 plus 2y. And then I'm going to solve and try and get this y by itself. Okay, so when I solve, I want to get rid of the adding and subtracting first, and you're saying, but Mrs. Kaiman, it looks like it's adding 2y here. Well, really, I have got to get rid of this 8 first, and so I'm going to go ahead and subtract 8 because that's the opposite of a positive 8. And remember, when I subtract it from the other side, I want to put it next to it, not under it. Oh, I don't know if I can erase that. Oh, see, I knew that was going to happen. Okay, let's go down here. I had x equaling 8 plus 2y. Okay, hopefully you remember how the other information written down. I didn't mean to erase the whole thing. So this is subtract 8, and I write it next to it again. So subtract, not add this time, subtract 8 equals 2y. And so my final step then to get y by itself, that same times, so I'm going to divide. So I divide by 2. And remember, I like to write it underneath each one. And so I'm going to write it right here just because I'm running out of room. And then I'm going to show you what to do with that plugging in the 2. So this is really x over 2, and 8 divided by 2 is actually 4, so I'm going to put minus 4. Hope you're okay with that. And then remember, I didn't want to write the inverse function alone. I wanted to find what it was at 2. So this is my inverse function. Okay, now what does it equal at 2? So I'm going to take the 2 and I'm going to input it to the 2 here on the x. And so I get 2 over 2 minus 4. Well, 2 over 2 is 1. So 1 minus 4 is negative 3. And so my inverse function at positive 2 is negative 3. And that is my final answer. And you see that we got a single number out because we were given a value inside here to evaluate for. Okay, that's it. If you have any questions, please ask your teacher.